Throughout this presentation, we'll be focusing on which final design to use, as well as which materials are best to construct the collector out of.
There are a range of naturally occurring plants which purely serve the purpose of collecting water. For example, bromeliads, as pictured in Figure 2 on the right. The leaves of these type of plants have a convex shape, meaning that they form a curved arch away from the surface that they grow on. This shape allows for water to drip downward into the central tank, as pictured in Figure 3 on the right. This is pulled down by the force of gravity. The interior concave shape of the leaf also aids in gathering and shuffling the water. The edges of the leaf bend upward, creating a structure that looks like a miniature half-pipe. This water collection is helpful for the bromeliad because it enables the plant to collect life-sustaining nutrients from the standing water over a long period of time. Hydrophobic leaf surfaces of the bromeliad possess a highly irregular microleaf, thereby reducing adhesion and spread of water on the leaf blade. This hydrophobic concept is able to be translated to our design because instead of using millions of microscopic hairs, we could use the wax coating on our material in order to repel the water. In Figure 1, we are able to see how water droplets appear to be floating on top of the leaf due to the hydrophobic effect. It is essential for the design to be inspired by the environment because it ensures that the structure will seamlessly tie into the surrounding environment and won't appear out of place. Our inspiration was taken from some telephone poles which are designed to appear like a pine tree, as seen in Figure 1 and 2. These seamlessly tie in with their surrounding environment and don't intrude on the native wildlife. The importance of this for the environment is because if a human-built structure intrudes on the environment, it will scare away native wildlife due to the sudden change. Since our product will be utilised on farms, it means that it will be interacted with by wildlife often. Therefore, it is important that it features an environmentally friendly design.
So for our designs, we wanted to go with something that did have some good environmental cohesion, so it could be placed out in the bush somewhere, and not be a sore thumb, not be something that animals are deterred from. So looking at our criteria for what we deemed makes our product successful, first two, efficiency of water capture and accessibility to water storage. These are crucial to any water catchment system. They're the two building blocks: how efficiently water is captured and how easy it is to store the water after it's captured. And on top of this, we were rating it on its degree of environmental cohesion, how well it blends into the environment, how pretty much aesthetic it is. And then lastly, cost of production, because it's a money-making scheme. Some things are going to cost more than others, and we take that into account. So for our first design, the funnel, this is a good design because it covers a relatively large surface area compared to how much material you're actually using. Because of this, it is relatively easy to mass produce, doesn't take a lot to produce, it's cheap, it's good. Additionally, it's easy to attach to a water storage system because it just trunks on top of something like a water tank, and there you go, storage. Unfortunately, there are some disadvantages to this design. Is it lacks the environmental cohesion. It still comes off the design of the plant, but it doesn't look very aesthetic. Also, it's dependent on pre-existing structures, meaning it can't stand alone on its own. It has to be attached to something. Our second design, the tree, this is a good design because it covers the largest surface area out of each of our designs. On top of this, it is a completely independent structure, meaning you can place it out in the middle of a farm somewhere and just let it do its own thing, and you can have heaps of them scattered around. Also, it has good environmental cohesion. You chuck some green paint on it, it looks like a tree. It blends in. It's not really an eyesore. Your call on that one, though. Some disadvantages for this design is that it is potentially difficult to attach to water storage, because if you do place it out on a farm, how are you going to connect that to your water tank? So you're going to have a massive hose. It's hard to do. Also, it uses a lot of material, so it's very expensive to produce. Moving on, our third design, the gutter extension. This is a good design because it's easily attachable to any storage system. Like the funnel design, you just chuck it on a house, have a pipe going down to your water tank, happy days. It's also very cheap to produce because, again, it doesn't use a lot of material. However, it lacks the environmental cohesion. It's just something you put on your house. It doesn't look nice, doesn't look fancy. It also has the least amount of additional surface area, meaning less efficient rainwater capture, and is dependent on the pre-existing structures as well. So probably our worst design of the four. Moving on, our last design, the tree improved. It's our tree V2. It's a better version. This is good for all the same reasons as the original tree. It has large surface area, is independent structure, and has good environmental cohesion. Additionally, though, it has additional utilities, the trough and the shade compartment for farmers that have cattle. However, again, is exceptionally expensive to produce because it uses even more materials and is going to be difficult to attach to a water system. However, this is probably our best design, and this is the one we're going to be going with for our product.
Taxonomy of creative design offers a progression from imitation to original creation, measured in terms of form and content. It categorizes creative works into 5 different levels of creative design. Imitation is the least creative level, where the work is an almost identical copy of another work, whilst an original creation is completely original and unique in every aspect. We believe our product falls right in the middle at the combination level. A combination is a mixture of 2 or more works in a way that changes the essential form of content for both or all. Our design sits at the combination level, in between the variation and the transformation level. In a variation, the product is only a step away from the original creation, and it's very similar. One of our other designs was the same as our final design, except without a drinking trough, and that's why it would be considered a variation. Even though it had a bromeliad-inspired water funnel, it would still be essentially only a rainwater harvester, and therefore a variation. Even though our design is more creative than a variation, it isn't creative enough to be considered a transformation. This involves a new creation that slightly reminisces an old creation. Our design is not a new creation, but rather the combination of 2 existing creations. Our rainwater harvesting product fits perfectly in the combination level as it combines the conventional design and function of a traditional rainwater harvester with a drinking trough and a bromeliad-inspired rain-catching arms. Our rainwater harvesting device has a unique bromeliad shape to help it catch more water and a trough for cows to drink from. A combination must include the mixture of 2 or more works, which our design fulfills. In a functional sense, our product is a combination of the rainwater harvesting part and the drinking trough part. Our product can simultaneously provide both of these functions to the user. By combining the bromeliad's features and a cow trough with a rainwater harvester, we created a highly effective combination. There are some existing rainwater harvesting products that are very similar to our package design, but none resemble our final design. There are already rain harvesting products with a cone-shaped funnel on the top to increase the surface area to catch more rain. These products do not have the creativity or complexity of our bromeliad structure. Using a bromeliad-inspired funnel allows our product to look more natural and aesthetic, and also work as a shade provider for the cattle that come to drink. No other rainwater harvesting design that I am aware of has included a drinking trough for livestock. The drinking trough is completely unique to our design and is a personalised feature added for our target market, the farmers of South East Queensland.
So not only have we considered various designs for our water collection system, but we've also considered what materials would be best to construct the main structure out of, which will assist in improved manufacturability for the collection system, use cost-effective materials, and have materials that are extremely sustainable and low maintenance that will accommodate our user-centered and customer-friendly design. There are 3 main material categories that cover a wide range of different materials, all with unique properties, which have been considered and compared to ensure the most suitable material has been chosen. With that said, first off is our metal, which is aluminium, which has a fairly versatile tensile strength, which is between 40 MPa and 700 MPa. It's got a fairly low to mid-range elastic modulus at 69 gigapascals. It's very corrosion resistant, extremely cost efficient, excellent weldability. It does, however, have some electrical and thermal conductivity. With polyimide, once again, it's got a 72 megapascal tensile strength. Its elastic modulus isn't as good as the others, which is 4 gigapascals. It's very corrosion resistant, moderately cost efficient, excellent moldability, and no thermal or electrical conductivity, which is the same with fiberglass. That is, the same, extremely to moderately cost efficient, very corrosion resistant. Fiberglass also has a elastic modulus between 52 gigapascals and 87. But where it really stands out is its tensile strength, which is between 55 megapascals and 2,358 megapascals, which is pretty big. After much deliberation, we've determined that none of these materials by themselves would be suitable for the entire structure to be made out of. Rather, a combination of two would allow for a much more sustainable and cost-effective system. These two materials would be a combination of both aluminium, which will be used to construct the main stem and water trough, and polyimide, which will be used to construct the head and water collection system. The reason we have selected these two materials is for their unique and individual properties. We're using polyimide for the head of the water collection system because of its virtually non-existent thermal and electrical conductivity, which will assist in preventing it being a massive lightning rod in the middle of farmland. Excellent impact resistance, which will allow it to withstand hail and impact from weather, and its immense creep resistance in high temperatures, and also its corrosion resistance. The reason aluminium was chosen for the stem was because it is, able to be worked into different shapes, and which means it will improve manufacturability, like through the roof. It is extremely cost efficient. It's amazing corrosion resistance, and its low maintenance properties. To recap, we'll be going with the improved tree design and using polyimide for the head and aluminium for the main stem and water trough. One thing you can take home is that the more water you collect now, the better off you'll be when the drought hits.